Today we're going to talk about solving systems of linear inequalities by graphing. While I go through the videos, don't forget to take notes and write down the examples and do the survey questions at the end in your notes. So the first thing I do when I'm given two inequalities in a system is I'm going to graph these two inequalities. So to start, I know that this first inequality is going to start at the y-intercept of -3, and the positive 2 slope tells me I'm going to go up 2 and to the right 2. So I'm going to graph that line. And when y is greater than in my inequality, I'm going to shade above the line. So I'm going to graph my second line. I know my y-intercept is going to be at positive 2. 1/2 slope tells me I'm going to go up 1 and to the right 2. Remember, I do a dotted line anytime there's no or equal to in my inequality. So I know I'm going to shade below my line, so I'm going to go ahead and shade that in. Keep in mind that this little part up here in the top has no shading, which means that that part doesn't satisfy either inequality. So what we're going to do is test some points, and we're going to determine whether they satisfy number 1, number 2, both inequalities, or neither inequality. So first is the point 2, 3. It satisfies only number 1, because remember, on that dotted line means everything on the line is not included, so it only satisfies number 1. The 0.45, it's on the solid line, so it also satisfies number 1. The 0.43 satisfies only the second inequality. And the -10 satisfies both inequalities. So I'm going to go ahead and graph the rest of these and label them with either a 1, a 2, both, or neither, depending on which inequalities they satisfy. Alright, so I'm going to go ahead and do the same thing and graph these lines. Here's my line for y is greater than or equal to 2x minus 1. And since y is greater, I know I'm going to shade above the line. And here's my graph for y is greater than -x plus 3. Since y is greater, I'm going to shade above my line again. So remember, number 1 is going to be those that only satisfy my first inequality. Number 2 is going to be those that satisfy only my second inequality. Both is my true solution. So when I'm asked to solve a system of inequalities, I want to know where my shadings intersect. So that's my solution. And then neither is going to be where there is no shading at all. So again, I'm going to graph this line. Y is less than -x minus 3. And I know that less than means I'm going to shade below the line. And here's my line for y is greater than or equal to -x plus 2. Since y is greater than, I know I'm going to shade above the line. So the orange shaded section is going to be my number 1 again. The blue is going to be my number 2. Now remember, my solution is anywhere where my shadings intersect, and neither is going to be where there's nothing shaded. So since nothing intersects, the answer to this would be no solution, because there is nowhere on this graph where my shaded areas are going to cross. Alright, and here are the lines for these inequalities already graphed here. For the orange, I know I'm going to shade above because x is greater. And for the blue, I'm going to shade below because y is less than or equal to -x plus 2. So my number 1 value is going to be those that are only shaded in the orange. And my number 2 values are going to be those that are only shaded in blue. But and there are no neither categories in this, but what we really care about is the both, the section where my shadings intersect, because that's the solution to my system of inequalities. And like I said, there are no there's no neither in this section because the whole graph is covered with, is shaded. So how do I determine the solution when I'm graphing systems of linear inequalities? So make sure that you shade the correct side of the line. If you're ever not sure, you can always test a point. So pay attention to where the shadings cross or where they intersect, because that's the true solution of the system of inequalities. Sometimes there is no solution when the shadings never cross. So if your shadings don't cross at all, that means no solution. Even if the lines don't cross, you still might have a solution if your shadings cross, so be careful. Make sure you always shade it. The solution is where the shadings intersect. So anywhere you have where your shades intersect, that's your solution to your system of inequalities. So don't forget, did you take notes for this video? Take the survey out here on the next slide. Bring any questions that you have to class tomorrow, and make sure that you know how to graph linear inequalities, because this is going to be a lot of what we're practicing tomorrow. There will be lots and lots of practice tomorrow, so make sure you can do it. And here are your survey questions. Have a good night.